Okay, so for problem number 1, it says you push a 25 kilogram wooden box across a wooden floor to the right with a coefficient of kinetic friction of 0.2 at a constant speed of 1 meter per second. How much force do you exert on the box? And this is the answer. Okay, well, so once again, let's read this again without any of the numbers. So you push a wooden box across a wooden floor to the right with a coefficient of friction, constant speed. How much force do you exert? Okay, so that's the situation. Let's see. Let's pull out all of our, let's do our free body diagram first. So we have here a wooden box and we're pushing it across the floor. Once again, what are the upward and downwards forces acting on the box? What is the downwards force? You should know this by now. If not, review the previous section. What is the upwards force? Okay, so we're pushing this box. It says that, right? Yeah, we're pushing a box across the floor to the right. So how are we going to indicate this here on our free body diagram? Let's say that we're pushing this box to the right. That indicates a push rather than a pull. And what kind of force is that? I'm going to say that that's an applied force. And do we have an opposing force? Well, yeah, that's going to be our friction force. What kind of friction is it? Are we moving the box or is the box at rest? Well, it's in motion, so therefore we know it's kinetic friction. Okay, so we have our free body diagram right now. Let's pull out all of the given information that we have. So, going through here, what does this 25 kilograms represent? Well, that is our mass of the object. Okay, and okay, what is this 0.2? Well, that's the coefficient of kinetic friction. And remember that the coefficient of kinetic friction symbol looks like this. That's mu. So once again, this is mu, and that's a Greek symbol. Okay, at a constant speed of 1 meter per second. Hey, I'm going to tell you this. I don't care it's moving at 1 meter per second. I care the idea that it's moving at a constant speed. If it's moving at a constant speed, trucking along like this, what would you say is the acceleration of the box if it's moving at a constant speed? Hopefully you're saying to yourself that the acceleration is 0. I'm sorry, I forgot to include this here. And our acceleration is equal to 0 meters per second squared. Okay. In which direction is acceleration? Is this acceleration in the y direction or is it in the x direction? Well, if it's going like this, I would say it's the acceleration in the x direction. Okay, just a quick pause here. I want to explain this. So far, we've actually described our acceleration due to gravity, our acceleration in the x direction, and we will be discussing our acceleration in the y direction. Understand the idea that none of these are equal to each other. These are all completely different values. Get that stuck in your head right now. This is acceleration due to gravity. What's the value of that? You know that number. 9.8 meters per second squared. Once again, we're saying that it's 9.8 meters per second squared, not negative 9.8, because the negative indicates the direction. The direction we're going to be saying over here is already going to be accounted for by the fact that we're indicating that this is a vector in the downwards direction. We don't want to account for that twice. The acceleration in the x direction is going to be moving left or right. The acceleration in the y direction is whether or not the object is moving up or down at all. So keep in mind that all three of these accelerations are different values. None of them are the same. Okay, and very last thing here. So once again, this indicates our acceleration is equal to 0. And the very last thing is asking us, how much force do you exert on the box? Wait a minute, so what is this asking us? What force is this? How much force do you exert on the box? What does exert mean? Well, you know what? exerting a force on the box. That sounds like, hey, you know what? I'm going to be pushing the box, right? So that is indicating to us what is our applied force. We're going to be figuring out what this is equal to. Okay, so we set up our free body diagram, we pulled out all of our given information, and next thing I want to do is this. I'm going to erase this over here. Next thing I want to do is this. Let's go back to Newton's second law of motion, where it says force is equal to mass times acceleration. We could actually expand on this a little bit more. We could say that all of the forces, or the summation of the forces, in a certain direction, let's say the y direction, is equal to mass times the acceleration in the y direction. So this is basically, we're going to be saying, hey, you know what are all the forces acting in the y direction? We could similarly say, come over here and say, hey, you know what? Also, let's evaluate all the forces acting in the x direction and set that equal to the mass times the acceleration in the x direction. If I'm to actually take the summation of something, let's do a little side note over here. If I'm to say, hey, you know what? We have 3x plus 2x minus 4x plus another 3x. And I was to take, hey, you know what is the summation? What is the summation of all of these x's? All I'm going to do is combine all of them, right? So I have 3x plus 2x, well, that's 5x, minus 4x, well, now we're down to 1x, plus another 3x, and now we're backed up to 4x. That's the summation of all of the x's. I know we're saying summation, and you're thinking to yourself, hey, you know what? That's having to do with plus. Well, it also kind of accounts for the negative as well. Let's just basically say it's a summation of all the x's, including the subtractions of them as well. So that's what we're going to do. We're going to add and subtract all of our forces in the y direction, same thing in the x direction. But first, what we're going to do is this. We got to actually say what the positive direction is. Let's say for this one, our positive direction is going to be upwards, as well as being that the object is moving to the right. We're also going to say that the right direction is positive. And you might be saying to yourself, hey, you know what? That makes sense, because if I'm to be working with a Cartesian coordinate system where we have our y over here and our x over here, this is going to be the positive direction, and this was also going to be our positive direction over here. But that's not the reason why we're going to be indicating that the right is the positive direction in this situation. We're going to be saying that the right is the positive direction because the object is moving to the right. And that's the reason why we say in this situation that the right is the positive direction. Now, what is the force due to gravity acting on the object? Well, that's the mass times acceleration due to gravity, right? And we have the mass already, so therefore we could find out what the force due to gravity is, which is the weight of the object. And that is equal to 245 newtons. Okay, so coming back over here, we have the sum of the forces in the y direction. Well, we just indicated the idea that upwards is going to be our positive direction. So what we're going to do right now is look at our free body diagram. I'm just going to scan from left to right and looking for all the forces that are moving up and down. Hey, you know what? We have the two forces that are moving up and down, the normal force and the gravitational force. Well, being that upwards is our positive direction, we're going to say that all the forces acting upwards are going to be positive. So that is our normal force. And therefore, all the forces acting downward are going to be negative, which is our force due to gravity. And that's equal to mass times acceleration in the y direction. Hey, I have a question for you. Is this object moving up or down at all? Well, no, right? So therefore, what would you say is acceleration in the y direction if it's not moving up or down at all? Well, the acceleration in the y direction would be 0, so therefore, because it's not moving up or down at all, so therefore, how could it have an acceleration in the y direction? It would just be 0 times any number, the mass, would also be 0. So we know that the normal force minus the force due to gravity is equal to 0. And that is the setup for our sum of the forces in the y direction equation. Let's come over here. Let's figure this one out. we already determined before that the right direction is our positive direction, being that that object is moving to the right. What are all the forces acting to the right? Let's do our scan. And we see that the forces acting to the right are the applied force. Are there any other forces acting to the right? No. What about to the left? Well, that's our kinetic friction. And being that it's moving to the left, we're going to say that that's a negative force, a negative direction. Okay. And that's equal to our mass times acceleration in the x direction. Well, we're given the idea that our acceleration in the x direction is 0 because it's moving at a constant speed. That being the case, once again, this is also 0 because it's moving at a constant speed. So 0 times any number will also give us 0. And that is where we're going to stop with this problem.